Hi, I'm Brock Dyer. I'm a chemistry major, graduating class of 2025, hopefully. Physics minor, currently doing physics research, technically.
And I'm Dr. Ross Martin Wells. I'm a professor in the physics department, and I teach the modern physics class, which tends to include the sort of the basics of quantum mechanics. And so from time to time we get interested chemistry majors who find that kind of application, which chemistry is famous for using the applications of quantum mechanics, that we can excite some students about the basics of it. And Brock is interested in that world in between chemistry and physics. And so this summer, that's why we decided to start working together. And so what kinds of problems are you interested in solving with this combination of chemistry and physics?
Well, one of the things that I've noticed in my typical, during the semester research, in a brief exploration of computational chemistry, is that there's a lot of problems in basis set selection and proper geometry optimization methods, mostly with density functional theory and Hartree-Fock methods, because they're just an approximation. So I think it would be nice if I could get more real answers, closer to reality, with the application of machine learning, because it seems like exactly the tool to use for this sort of research.
If we've got these basis states that you're learning about, right? You're learning about, and you came down this morning to talk about rotations and eigenkets, which are basis states, as we're talking about, right? And we're hoping to then apply those when we have two atoms instead of just two beautiful spin states, and connect them in some way to make a molecule, right? And so machine learning is going to help us with that in some way, right? What are we hoping it's going to help us do?
Well, we're hoping that we can input data from real measurements, molecules that exist, and then train an artificial intelligence on those molecules that we know their properties, and apply it to simpler things and eventually more complex things, so that we can get a real picture of what's going on. I think in 6 weeks, I would like to have found a reasonably advanced system that I could apply to almost any molecule that I would desire. An artificial intelligence, a neural network that I could use on a supercomputer to calculate the potentials for any molecule.
How do you find something?
Yeah, we just
Yeah, me too.
We'll get something, right? And the other thing is, right, because this is a teaching research opportunity, if the research ends up being a complete bust, that will still make Brock into a better scientist, which is the point, right? So I, as the advisor, my job is to make sure that he learns something, right? And so that will happen no matter what. And then the hope is that there's an exciting result also underneath it that is good for all of science, not just the young scientist.